Why does Netflix load fast in Cairo and also fast in Tokyo? Why doesn't WhatsApp stop working when one data center goes down? Because global apps are designed for regions, not for a single server. Let's talk about designing for global and multi-region apps. The core global challenges: when you go global, you will face high latency across contents, different legal requirements, cultural differences, currency and payment variations, and time zones, network instability, regional outages. Single region architecture cannot survive globally. Multi-region backend architecture. Instead of mobile single data center, you design mobile closest region, regional backend, global data sync layer. Regions might include US, Europe, Middle East, Asia. Each region handles local user traffic, regional caching, local compliance. Global layer handles cross-region consistency, data replication, and conflict resolution. Latency optimization strategy. Latency is physics. Data traveling from Egypt to US adds delay. To reduce latency, use regional servers. GeoDNS routes user to nearest region. CDN for static content, images, videos, configs served from edge nodes. Edge authentication. Validate tokens at edge before hitting origin. Connection optimization. Use HTTP/2 or 3 persistent connections compression. The goal to keep API response under 100 to 200 globally. Data replication strategy. Multi-region means data exists in multiple places. Models, primary replica, one main region, others read-only replicas. Simple but risk of higher write latency. Multi-primary, multiple writable regions. The complex requires conflict resolution used by large-scale platforms. Architect must choose based on write frequency, regulatory needs, consistency requirements. Offline first strategy. In many regions, unstable internet and slow networks and expensive data. Offline first architecture. Local database equals single source of truth. Sync engine runs in background. The flow, user action, stored locally, UI updated, sync when connection available. This improves perceived performance, reliability, user trust, especially important in emerging markets. Localization beyond translation. Global apps must support multiple languages, right to left layouts, currency formatting, date and time formats, cultural user experience differences, architectural consideration. Localization must be dynamic, versioned, updatable remotely. Hard-coded strings are not scalable. Also consider payment providers per region, regularity differences, tax calculations. Localization is system level. Server selection strategy. How does app choose backend region? Options: DNS based routing, user routed based on IP, latency based routing, fastest region selected dynamically, manual region assignment, user assigned region at account creation. Important: user must remain consistent with region to avoid data inconsistency, compliance violation, payment issues. Region switching must be carefully handled. Regulatory and data residency constraints. Some countries require user data stored locally. Example constraints in EU GDPR. Some regions, financial data residency. Architecture must support regional storage isolation, data segmentation, and region-based backups. Not all data can move freely across borders. Handling regional outages. What if Europe region goes down? The strategies: automatic failover, read-only fallback mode, queue writes locally, redirect traffic to secondary region. Mobile must handle temporary degraded mode gracefully. User should see limited service available, not crash. Versioning and backward compatibility. Global scale means millions of users on different app versions. You cannot assume everyone updated. Backend must support older API versions, handle deprecated endpoints, maintain compatibility window. Architect must define API version lifecycle policy. For example, user in Egypt sends message to Japan. The flow: Egypt client in Middle East region, message replicated globally, Japan region delivers locally, push notification triggered. Latency optimized by regional processing, global replication. Consistency managed by event-based synchronization. That's global architecture. The architect mindset. When designing a global app, ask yourself, what is maximum acceptable latency per region? What happens if region fails? Is data residency required? How do we sync across regions? Can user move countries? How do we localize payments? Is offline first required for this market or no? Global design is distributed system design. Designing global and multi-region apps requires geo-distributed backend, latency-aware routing, CDN and edge optimization, data replication strategy, offline-first architecture, localization and compliance awareness, regional failover planning. When you design globally, you stop thinking about servers. You start thinking about containers. Thanks for watching and see you next video.